Okay, so today we're going to talk about the second fundamental theorem of calculus. If you want to go back and see the first fundamental theorem of calculus, that was section 4.3, but that was basically just saying if you want to find a definite integral, that you take the antiderivative and plug in the top bound minus the bottom bound. So we're going to do something a little different today. We have this function that's defined here. Big F of x is the integral from 1 to x of f of t dt. And so we've been asked to find f of x and f prime of x in terms of x. So we'll start there. So we're given f of t in this problem. So let's write f of x. So first of all, you should notice a couple things about this equation. So this is a little bit different because there's a constant here at the bottom of my integral, but there's a variable at the top. And usually we're used to seeing constants on both of those. You'll also notice that the variable here, x, is different than the variable on the inside, t. And so that has to be, so like if we're finding like f of 5, we would just plug in 5 here on the integral and not in the integrand, so not on the function itself, so just on the integral. So what we're going to do is go ahead and figure out what the equation f of x would be without the integral. So that means we need to actually take the antiderivative. So we're basically going to treat x just like it was a number and do the same kind of process. So this is us using the first fundamental theorem of calculus. So the antiderivative of 4t is 2t squared, and the antiderivative of minus t squared is minus 1/3 t cubed. And then we're going to evaluate it from 1 to x. So that means we have 2x squared minus 1/3 x cubed. So I just plugged in x for t. So you notice that's also another reason we had to have x here and not t's, because it wouldn't really make sense to plug t into t. So x we can plug in for t. Minus 2 times 1 squared, so 2, minus 1/3. If we simplify that, it's 2x squared minus 1/3 x cubed minus 5/3. So that's our equation f of x. It's equal to this integral that we started with. The second thing that we're going to find is f prime of x. So we're just going to take the derivative of that polynomial we just found. You get 4x minus x squared. The derivative of negative 5/3 is just 0, so that cancels out. Okay. So take a second and see if you notice anything about f prime of x. So hopefully you realize this is really the same function that we started with up here, 4t minus t squared, except that this has x's and the original equation had t's. So let's try another example and see if we get the same thing. So we're going to write big F of x. That's the integral from 1 to x, cosine of t dt. So we're going to take the antiderivative. Remember, the antiderivative of cosine is just sine. It's not negative sine, it's positive sine from 1 to x. And so that would just be sine of x minus sine of 1. So again, take the antiderivative and plug in your bounds. We're going to take the derivative of that. We take the derivative of sine of x, which is cosine x, and then the derivative of minus sine of 1. So sine of 1 is a constant, so the derivative of that will just be 0. And so again, we get f prime of x equals cosine x. So it's our original equation. So what we're really doing here is taking the derivative of the integral. And what it seems to happen is that it seems to cancel out. Notice that we got the same things without the integrals. Let's take a look at another example and see if that still happens if we change it around a little bit. All right, so now we have a new definition of big F of x. It's the integral from 1 to x squared of f of t dt. So we're still going to write it out the same way we did before. You'll just notice there's an x squared instead of an x. So we'll go ahead and take the antiderivative. Antiderivative of t cubed is t to the 4th over 4, or 1/4 t to the 4th. We're evaluating from 1 to x squared. And then if we plug this in, we have x squared to the 4th divided by 4 minus 1 to the 4th divided by 4. So that gives us x to the 8th divided by 4 minus 1/4. We're going to take the derivative of that. The derivative of x to the 8th is 8x to the 7th. We're still dividing by 4. The derivative of minus 1/4 is just 0. And so that gives us 2x to the 7th. So you'll notice in this case, this is not the same thing that we started with, t cubed. So it doesn't seem to work in this case like it did in examples 1 and 2. Let's try to look at another example and see if the same thing happens or if we notice anything else. So we're going to do the integral from 1 to x squared of f of t dt. Oops, sorry, we want to go ahead and actually plug in what the f of t is. So remember that is 6t to the 1/2. So you might want to rewrite that first before you take the antiderivative. So the antiderivative of t to the 1/2 would be t to the 3/2, and then we divide by 3/2 or multiply by 2/3. Evaluate from 1 to x squared. So 6 times 2 over 3 is going to give you 4. So 4x squared to the 3/2 minus 4 times 1 to the 3/2. X squared to the 3/2 would just be 4x cubed. So the 2's cancel out. Then minus 4. If we take the derivative of that, we get 12x squared. Okay. So again, notice in this example that once we had this constant, we take the derivative, it's 0. It's the same in the other examples too. So again, this didn't work out. 12x squared is not the same as 6 radical t. So there is something else going on here, and that's where the fundamental theorem of calculus comes in. The second one in particular. So we're going to start out and just think about this type of integral. So the integral where you have a constant and a variable. So we're going to say if the integral from a to g of x of f of t dt oh, sorry, I need to say that that's f of x. I'm going to rewrite this. If big F of x is equal to the integral from a to b, a to g of x, I'm just making lots of mistakes, f of t dt. So you'll notice a couple of things here. A is the constant. It could be any constant you want. G of x is just some variable form of x. It could be x, it could be x squared, it could be 3x, it could be anything, any function of x. Then big F prime of x is equal to f of g of x times g prime of x. And so this is really a consequence of the chain rule. So what we're doing here when we take our antiderivative, or when we take our derivative, sorry, we're going to take this g of x, we're going to plug it in for t. So wherever there was a t, we'll put in that equation. So that's this right here. But then thinking about chain rule, we have to go back and multiply by the derivative of the inside. And so that's why we have to multiply by g prime of x. So let's compare this to the problems we had on the front page. So for this first problem, we had f of x equals the integral from 1 to x of 4t minus t squared. When we found big F prime of x, we found that it was just 4x minus x squared. We noticed that was the same thing as the integrand, just with t's instead of, or with x's instead of t's. So if we use the second fundamental theorem of calculus, we can take this x, we'll just plug it in for t's, and then rewrite it. So 4x minus x squared, but then we need to multiply by the derivative of x, which is just 1. So that's just 4x minus x squared. Same idea with the second one. We had the integral from 1 to x of cosine of t dt. When we found f prime of x, we found it was just cosine x. So again, using the second fundamental theorem of calculus, we're going to take the x, we're going to plug it in for t, and so that's just going to be cosine of x, and then we need to multiply by the derivative of x, which is just 1. So that's just cosine x, once again. So notice in both of those cases we got the same thing that we had gotten on the previous page. It's just a lot easier, less steps, less work. And you'll notice the reason why we got the same thing that we started with was because there was just an x in on our integral. And so the derivative of x is just 1, so that's why it's the same thing. If we look at the other two cases, it's going to be a little bit more complicated. Not much, but a little. Okay, so when we had t cubed, we had taken when we got our derivative, we had gotten x to the 7th times 2. And so if we look back at our integral here, let's use the second fundamental theorem of calculus to find that. So we're going to take the x squared and plug it in for t. So f prime of x is equal to x squared cubed. So we just replace it with the t. And then times the derivative of x squared, which is 2x. So that's x to the 6th times 2x, or 2x to the 7th. So that checks out. So that's why we had that extra term there, because we had to actually plug in x squared and then multiply by the 2x. So that gives us the rest of our equation. All right, when we did the integral from 1 to x squared of 6 radical t, we got 12x squared, or was it just 12x? Nope, 12x squared, okay. All right, so let's use the second fundamental theorem of calculus. Take the x squared, plug it in for t. So f prime of x is 6 square root of x squared, and then multiply by the derivative of x squared, which is 2x. So this just gives us 6x times 2x, which is 12x squared. That checks out. All right, so let's do the same thing with these other functions. We're just going to go straight through the second fundamental theorem of calculus. We've got the 2x. So you're looking for your bound that has an x in it. We'll take the x, plug it in for t. So we have square root of 2 minus the quantity 2x squared, and then times the derivative of 2x, which is 2. So this is just 2 square root 2 minus 4x squared. You don't have to take the derivative of anything with the function that's inside the integral. It's really just taking the derivative of your bound. All right, next one, g of x. You might notice that the function is on the bottom of the integral now instead of the top. And so we just need to switch that around, and when we do that, it will just be negative, just like we've been doing before. So g prime of x equals, take the x squared and plug it in for t. So negative e to the cosine of x squared times now the derivative of x squared, which is 2x. You can leave your answer like that. Okay, I want you to try h of x on your own, and you can check your answer in the next video.